All right, let's work with apothms first. So an apothem is kind of like the radius of a regular polygon. So right here, if I wanted to find the area of this shape, I would need the apothem times the base divided by 2. Why? Because I'm making this triangle right here. So the apothem, 7 times 6, that's going to give me 42. I'm going to cut it in half, and that's going to make 21, which means this triangle is 21. Now, how many triangles do I have inside of this specific shape? I have 5. So then I would have to multiply this by 5, and I would get 105 as the area of this shape. So that's how you use the apothem to find the area of a regular polygon. Now, let's talk about parallel and perpendicular. So if the slope is 1/2, the parallel slope would be exactly the same, starting in different places so that it creates a parallel line. If you're looking for something perpendicular to 1/2, it would have to flip and change signs, causing it to be -2. Now, let's do -5 just in case, another example. So -5, if I wanted something parallel to -5, it would be exactly the same slope. If I wanted something that is perpendicular to -5, I would have to flip it, causing it to be 1/5 and changing it to positive, so it would become 1/5. So that is a perpendicular slope to this one. That is a parallel slope to this one. Now let's talk about this one. Are these congruent? SSA is not really one of them, but why is this congruent? Because this is a special system using a right triangle called the hypotenuse leg theorem. The hypotenuse leg theorem works only on right triangles because I have two sides of the right triangle that are congruent. Because of the Pythagorean theorem, this side has to be exactly the same because a squared plus b squared equals c squared. Now we're going to talk about circumcenter, incenter, centroid, and orthocenter. Very similar wordings, so a lot of people get them confused. Let's see if we can fix that. So, circumcenter, you use perpendicular bisectors, which means you're cutting the sides in half at a 90-degree angle, to find the points that are equidistant from the angles. Incenter is the complete opposite, meaning I'm going to do angle bisectors to find a point that is equidistant from all the sides, because it creates a circle inside of the triangle. The circumcenter creates a circle outside of the triangle. These two are complete opposites. If you know one, you will know the other because it's the opposite. Now, the centroid uses medians. You'd think it would be finding the middle of something because it's using the medians. It is not. It is cutting every point inside of the triangle into a 1/3, 2/3 piece. So if this piece was 5, this piece would be 10, causing the entire length of that piece to be 15. Orthocenter, you use altitudes. Now, using the altitudes, where the altitudes intersect, also called heights. Sorry about the spelling. Altitudes, also called heights. If the point ends up inside, the triangle is acute. If the orthocenter ends up on the actual corner of the shape, it is a right triangle. If the orthocenter ends up outside, it is obtuse. Now let's talk about parallelograms. So parallelograms. The special thing about parallelograms is the top is equal to the bottom, the left is equal to the right. This angle is congruent to that angle. This angle is congruent to that angle. The top is parallel to the bottom. The left is parallel to the right. And these bisect each other. Okay, so we'll cut in half. They'll be cut in half. What is special about a rhombus? All the sides are the same, and these will intersect at 90 degrees. Okay? Everything else is pretty much the same as the parallelogram. That's what makes this special. Now, what's special about a rectangle? This is equal length to this. That is special for a right triangle. So that means when these are bisected, they're all equal length. Also, every corner is 90 degrees. That's also special about a rectangle. What's special about a square? It has everything. Everything is equal. All the corners are 90. When I cut these in half, all of the angles are now 45. All of these lengths are exactly the same. All the centers are 90 degrees. Every single triangle is exactly the same. Everything about the square is exactly the same. Why? Because it is a rectangle, and it is a rhombus, and it is a parallelogram. So it has everything from all the shapes. Last thing I'm going to go over is similar right triangles. So let's say this length is 12, and this length is 3, and I'm looking for this length. Okay? This length here is part of, all these triangles are going to be similar. So if I use the small side of the triangle and the small side of the medium triangle here, you're going to get x. Then I'm going to have 12 as the larger side, not the hypotenuse. 12 is the larger side, and that goes with this x here. And this is the larger side of the small triangle. So the small triangle's on top and the medium triangle is at the bottom. Why did I set it up like this? So that I can figure out what x is. Cross multiply, you get 36 equals x squared, square root 6 equals x. I know it went fast, but you can slow down the video or something. Bye.